Hello. Today we are going to code a smooth scrolling text using assembly with Commodore 64. First off, let's explain these three instructions. The first one is an assembler directive. This way the code that follows this instruction will start from memory location 1000. Second one, it's a kernel routine that clear the screen. The third one is used for setting interrupts. It is often followed by some poke on CIA and raster register interrupts. As our first purpose, we are going to display a message to the screen. Okay, here we make the accumulator point to the message address location and we set the X register to 0. Then we create a loop that cycle each byte of the message and write it starting from address location 400, which is the default pointer to screen memory. The loop continue until accumulator contains a byte different than 0. For the second step, I want to print each character of the message every 50 frames. Since we are on a PAL system, the time lapse between each character to display is about 1 second. Look at this snippet. The first part checked the raster beam position through the register D012. So loop on itself until line 0 is reached. To make sure that we don't back to the main loop with the same raster line so we could accidentally skip some frames, there is a second loop that make the opposite check. It works. Each letter is printed every 50 frames as expected. Okay, before continue, I save my code to ASEQ file so I can clear and make a little snippet that show how hardware horizontal scroll works. Now, the register responsible for horizontal scrolling is D016, specifically the last 3 bits. Because we don't want the characters on the left to suddenly disappear, we reduce the visible columns from 40 to 38, so we set the register's bit 3 to 0. As we can see, the more the bit 3 value is greater, the more the character will be displayed to the right. Okay, we can back to our project and load the SEQ file previously saved. Next step is to create a software scrolling text. Each character will shift each seconds by an entire column, in other words, 8 pixels. To accomplish this task, it is enough to copy all visible characters to the left, and then print the new character at the last column on the right. Since the column visible are 38, this character won't be shown at begin. Good. Now we have to add the hardware scrolling. We'll make pixels shift each 1/8 of a second. Here there's a bit of logic. If x offset is greater or equal than 0, we make shift the screen by 1 pixel to the left. Otherwise, we reset the scroll bit value to value 7. We move each character by 1 position and we generate the next character on the right border as shown early. Great, the scrolling text example is completed. Thanks for watching this video.